Hey, welcome to Programming Rainbow. In this video, we will continue on the series, The Beginner's Guide to SDL2 in Haskell. If you're just starting out with this video, you can go to github.com, Programming Rainbow, Beginner's Guide to SDL2 in Haskell. You can clone that repository, move inside the directory. And this is, let me just open it up. You can open it up in whatever editor you feel comfortable with. We are looking inside the app directory inside when you're inside the beginner's guide directory, inside of that, when you open it up in your editor, the code is in the app directory. So this is the 6th video. The last video is the 5th video. So I'm looking at the code that we left off in the last video. But if you just clone this repository, you're probably looking at the code for video 8, the final code. So you want to go inside the video 5 directory and you'll want to copy that main.hs into the app directory. So let's just show off where we left off with in the last video. I'm using stack run to run this. And what we have here is we have a window that's 800 by 600. It has a black render being displayed right now. It has a background image that is partially transparent, but also says Haskell. If I press spacebar, I can change the color of the render that shows through the transparency of the background image. We also have troop type font text up here that is displaying Haskell. And we have a title. We also have an icon that has been loaded that I can't show right now in my tiling window manager, but it is there. In this video, we're going to make this true type font text, this rectangle that's displaying it. We're going to move this rectangle around, and that's going to make the text move around. So we're going to have it bounce off the sides here. And that's what we're getting into. We'll be making use of the state transformer monad for this. Okay, so the first thing I'm going to do is just change the title here to moving text. So I've changed the title here to 06 moving text. Okay, so one thing that we did in the last video is that to draw the Haskell text correctly, we created a rectangle. And we stored that rectangle in game data. This rectangle right here is being stored in game data. It is actually being created in the load media function down here. So we had this surface that we've created. We did convert the surface to a texture, but we could also grab the dimensions from the rectangle. We did that in the last video. And we were able to generate a text rectangle from this, and we stored it in our game data. Now everything that's in the game data doesn't change during the game. And we want to modify this rectangle during the game loop. So we don't want it to actually be in this game data. We already have something set up that we can modify during the game. And what it is the state T monad that we set up, that we created these add clean for. Right here, this game state. This is something we can change. We're not really mutating it, but we're using the state T transformer applied to game state to handle state. So we have been using it to build up these actions, but we can actually just store our rectangle in there, and then we could change the rectangle that state T game state monad will handle this. So that's what we're going to do. So the first thing I want to do is move the rectangle out of the game data right here and move it into here. But we're also going to need an initial state for this. Okay, so I'm just going to take it right out of here. And this is going to cause some errors before we clean it all up. So don't worry about getting errors. So it's already not happy with this. Let's see here. The constructor of new. Okay. So we can only use new type if we have one field in here. So now we're going to change this to data. We're going to have lots of more errors. So don't worry about any errors right now. But we do need to create an initial state for this. So since this is a rectangle, what I'm going to do is I'm just going to make an empty rectangle. So it's called game text rect. And what it is it's an SDL rectangle, right? So the SDL rectangle constructor. And we know the first, let me just show you this rectangle again down right here where we've created this rectangle from the surface dimensions. This is what we're looking for right here, this rectangle. Okay, So this is the constructor, SDL rectangles constructor. And the first one is a point. So it's a vector2 wrapped in a point. And the second one is a vector2. So both of these are wrapped inside of this rectangle. So we need to satisfy all of this. And what I'm going to do is I'm going to add 0 here, 0 here, 0 here, and 0 here. So it's going to be a rectangle that's at 0, 0 with no width and no height. That's just its initial state, because this initial state happens before we even know that the image has been loaded. So we can't put any dimensions in because we haven't actually loaded the image in yet, because this state needs to occur. We look down here in the main. This state is passed in first. This state exists before load media is actually, before this is evaluated. So this needs to happen first. So I'm just going to put in a rectangle with nothing, just an empty rectangle. And then we'll modify that rectangle when we do actually have the dimensions. So the easiest thing I can do is go down to where we have this rectangle right here. And I could just yank this right here. When I say yank, it's because I'm in NeoVim and VChad. Yank is how you kind of copy something. It's a Y. So if you hear me saying that over and over again, it's just in my head, I'm thinking Y. So down here, we just need this. So there, just paste it in, but we don't have this surface width, surface height. So what I'm going to do is just make both of these 0. Again, this is just initial state. So that's going to give us our initial state that now has this new field in it. And we've lost the field from game data, so we're still going to have errors down below. So on this load media, we're going to have this error here because we have this field that no longer exists. That's fine. And then when we are pulling it out here, we're going to have another problem as well. And it's going to complain here. I'm just commenting these out for a minute, so there's no actual errors anymore. So now we have our game state. Our initial game state has the rectangle initially in it. Let's go back up to it. Initial game state. It's right there. It's 0. So what can we do now to update this game state when we do have access to it? So down in load media, we have the rectangle now. So we don't want to put it in game data. We want to update our game state. Okay, and we've already seen how to do this. I'm going to use modify, and we've already seen it. So I'm just going to go up and copy it since we've already talked about it. Here it is. So we already have this where we're basically modifying a single field, right? So I'm just going to yank this because it's exactly what I need. I need to modify the game state. It's not going to be an action now. So we are going to change this, but this is the idea. Modify is this lambda. Game state is what we're going to call what we're getting out of the game state. We're just going to call it game state. And then we need to use our record update syntax to put it back. The game state, we're putting it back, but we're changing a field. So it won't be this field, but I'm just going to yank this just to be easy. So I'm going to go back down and I'm going to do it underneath right here before the return. So what we're doing is we're updating the game state. Okay, but we are updating text rect. And we can just use this text rect here that we have. So now our game state is not holding the 0, 0 anymore. Now it is holding whatever the width and the height is. That's how we have updated it. The reason why I just used modify is because we don't need anywhere in here. We're not getting the game state. We're not using get. We're not using put. So I could get it right here and then put it immediately. But since we're doing get and put all in one, I'm just using modify. But you can do it either way. Okay, so now the other problem we're having is down here. We are getting the game text from game data, and that's not going to work. So what we could do is we could get it from gets. We could use gets to get a specific field. So I'm going to do that. So I'm going to use gets just like we've used it before. And get. So that's going to get the specific field from game state. That's what gets does. Again, we've talked about this in a prior video. Gets is a way of getting, so we have get that gets the whole game state. Gets will get a specific field from our game state. Put puts it back into the game state. And modify will do a get and put on whatever fields you want using a update syntax. So gets our specific field from game state, which is our text.Rect that we want, and we're binding that the data from that monadic action to text.Rect, so that we can now use it again here. And yeah, that should all be fine. So right now, if we run it, nothing should happen. It should look exactly the way it looked before, except our rectangle is now in the game state. But nothing's happening with the rectangle, so it should just all look the exact same. There we go, yep. And we still having Haskell written up here. That means we did everything correctly. We're just storing that rectangle in a different place now, and we're getting it from that place. Okay, so we want to kind of update this. And I'm just going to open up my code and we're going to look through it and talk about it before we start implementing it. So this is in video 6 where I'm looking at this. And what I want to do is create a function that is update text. So here's our function that's update text. It's just in the same state transformer applied to game state in the context of IO. So this is the type annotation that we've been seeing all over the place. Right down here, it's all in the same context. So the first thing we're doing is we're getting the game state using the normal get, not gets, because we're not getting a single field, but we're getting the whole game state. So we got that here now. And there's two things I want out of this. I want the rectangle and I want the velocity. So we haven't created the velocity yet. We're going to need to go up and create that. But that's going to be something we're going to create. And the reason it's also going to be in game state is because the velocity on the X may be positive if it's moving this way. But if it bounces off the right side wall here, we need the velocity to be negative on the X. And the same with the Y. It may be moving down positively, and then it may bounce off the bottom, and it needs to be moving in a negative direction to move back up. So we are going to have this tuple in the game state that it has the X velocity and the Y velocity in it. So we're getting the X and the Y velocity out of game state as well. And again, we'll add that in later. I'm just kind of walking through what this code is going to do. We're using guards. Whatever's the first guard that is successful is going to be applied. So if our X velocity is less than 0 and our old X is also less than 0, then we're going to return 0 as our new X. And we're going to take the X velocity and we're going to flip it. So we're just multiplying it by -1. So no matter what it is, if it's 1, it's going to turn into -1. And if it's -1, it's going to turn into 1. We probably don't need to do it this way. The X velocity being smaller than 0 means we are moving to the left. And then if we check in our old X, if it's actually less than 0, that means we've moved off the screen to the left. All right. So now what we're going to do is we're going to set that X back to 0 because we don't want to be off the screen. Or we're going to make it go in a positive direction. So we could just make this statically be a positive X velocity instead of flipping it. That's an option as well. But I've just used this flip. So this is whatever the sign is of this is flipping it to the other sign. If it's negative, it's positive. If it's positive, negative. But we could actually just hard-coded this as positive because we know we need to start moving in the right direction. So anyway, if this first evaluation is positive, then this one will be true and this will be the answer to this let up here. So 0 will be applied to new X and again the flipped version of X velocity, and we may change this, will be applied to new X velocity. If X velocity is greater than 0, so we're moving to the right, and the old X plus width is greater than screen width. So if we're applying our width, so we're getting in the right side. So if we have a box, our old X is the left side of the box, plus our width right here is the right side, and we're getting that out of the rectangle. So we're getting the right side of it. If our right side is bigger than the screen width, so it's gone off the screen to the right, then we are setting it to screen width minus width, so it's not being drawn off the screen, it's being drawn completely on the screen. The left side of it will be now at the screen width. We're setting that to our new X, and we're flipping the velocity again. And again, we could just make this a negative, or we could just make this a positive right here. If neither one of these are true, then our otherwise is just going to be whatever the old X is, plus the X velocity, so we're updating it, and the velocity still stays the same. So our new X velocity is just going to be whatever the old X velocity was, because we haven't bounced off any wall, we're just updating it. We're doing the exact same thing for the Y. So this is kind of updating what our X and Y's are, and our X velocities and Y velocities. So we're going to recreate a new rectangle with those new X and Y using the same width and height. And we're going to use record update syntax to update the game text rect with the rect that we've just created here, and the new X velocity, new Y velocity. So that allows it to not only move, but when it hits the edge of the screen, it bounces back. And again, I think we can write this slightly differently, so we may explore that when we start writing it. I think I can write this differently. This doesn't really matter in this game, but we could also do the check first if we do the X plus. So this is gonna be the main thing that we're doing right here, just to make it move around. And then down here, I'm gonna show this version and then a simpler version, but this is running our text update. And this one is using gets to get that new updated version for the text rect so that we can draw it. So I'm running the update first and then grabbing the updated version of the rectangle afterwards. So let's work on this first. This is text update, and it's just in the standard context that we've been using the whole time of the game state t transformer applied to game state in the context of IO action. State t, game state, IO action. So the first thing we need to do is get the state. So I'm going to call it just game state. So we have this velocity. We haven't created the velocity yet. So we do need to do that as well up here. So I've made a text velocity here. This is pulled out into its own definition, but then it's also going to be held in the game state, because sometimes this may be positive or negative. So, but we're going to pull it out here into this definition. I think it's just int. Hold on, let me check. Yeah, no, I'm using a cint. That's because I'm using this with the rectangles, and the rectangles are using cint. And I have this at 3. So I'm just defining text velocity. Text vel is 3. And I do want to make a tuple inside of game state that is going to hold. Game text vel. That sounds good. Okay, so in our game state here, our initial game state, I'm just going to make an initial state of 0. game text. Sorry, they don't need to be 0. We've already defined them. So I'm going to use the definition in here, which means initially they're both going to be moving in a positive direction. So it's going to be moving from the top left corner to the bottom right corner, because X will be positive. That means it's moving to the right. And Y will be positive. That means it's moving from the top to the bottom. So since we've just defined it up here, right here, I'm going to use this as my initial value. For both. But this will allow me to change these directions later on since it's in game state. Okay, so we have that. Now we need to go back down to here. And what I want to do is use the rectangle and that to get the values out with matching. So we need to create these two. So we've already seen this rectangle. I'm just going to yank it again. Where is it? The rectangle right here. So this is in game state. So the field in game state is game text rect. And do we want them? So I'm just going to call this W and H. That's what I called it. And this one is old X and old Y. This one is a tuple. This will be old X vel, old Y vel, text vel, game state. Okay. It's just complaining. It's saying it's the last statement. So now we have access to width, height, our old X and our old Y velocity, our old X velocity, old Y velocity, and our old X and our old Y. So that's kind of all the things that we need to start working on these guards. So we want to let new X and new X vel. See how we've done it here. And we're just using guards here. I'm just thinking if I should change the logic of this right here. I kind of want to do it applied. I think I'm going to apply it because this is kind of basically getting the position from the last update. It's allowing it to go off on the last update. So it can be off the screen partially for one frame. This completely doesn't matter, but it's just in my head. I'm thinking about, I'm actually checking the last frame, where it was in the last frame. Did it go off the screen on the last frame? Or which I should be doing is checking, is it going to go off the screen on this frame? So yeah, so I think I'm going to do that. I think I'm going to apply the update in the check, if that makes sense. We'll see it here. So the first thing we want to do is check to see if we're off the left side, I guess. Old X plus old x val, if that is smaller than 0. So that's with it already applied. And so now we have old x val is less than 0. If this has gone off the screen, the first thing we need to do is set the old x to 0, so it's not off the screen anymore. And then we need to make sure that the new x velocity is actually a positive direction. So I'm just going to use the defined one that is up here. Instead of flipping the sign, I know I need it to be positive, so I'm just going to use this text velocity right here, which is already defined. So that's what it's going to return in this situation. It's going to be 0 for the new x, and the new x velocity is going to be the positive 3. Okay, now we're going to check the right side. So I do want to apply again. So it's going to be old x plus old x val, and then also plus width plus w. This is bigger than, and we've defined this above, it's screen width. To get the screen width right here, 800. So we can just use this screen width. So if that's bigger than screen width, this is saying when I update the rectangle's x with the velocity, so where it's going to be on its new frame, and I don't want the left side of the rectangle, I want the right side of the rectangle. If that right side, because I'm adding width to it, if that right side is now bigger than the screen width, that means the right side of this rectangle is moving off the screen. So if it's so if it's bigger than the screen width and it's moving in the right direction, so old x val is larger than 0. Now we need to kind of reset it. So we need our new x position is going to be screen width minus width of this rectangle, right? So we can go screen width minus w, and the other one is going to be, here it was moving in a positive direction, we need it to be moving in a negative direction. Okay. And if neither of those situations happened, the otherwise, I just need to update. So I just need new x to be old x plus old velocity. And I need new velocity to just be old velocity. So old x plus old x val, this should be capital X. And then old x val. Okay? So this exact same thing is going to play out for the y. So I'm going to yank this. And I'm just going to make the y version of it. That's y. This should be a large x here. Okay, and this is not going to be width, it's going to be height. And this is screen height. Okay, hopefully we're getting closer. So that is creating new X and new Y. So we need to create a new rectangle now. So I'm just going to yank this right here. It's going to be similar to that. So we'll call this text.Rect, I guess. And I'm going to construct it with the new X, new Y, the same width and height. And we also need the tuple, but we don't need to do it here. We can just do it on the return. And we need to use the record syntax to update the text.Rect and the text.Rect velocity. The game state is what we pulled out up here. Yes. Okay. And we have the rectangle. That's the game text.Rect. Rect. Game text. Is it just vel? Yeah. And this is just the tuple of new X vel and new Y vel. Okay. So probably done something wrong here. Variable not in scope. Plus X. Plus X. It should be plus W, and this one should be plus 8. Well, I guess I just had an indentation problem, and also I had some X's written here. Hopefully that fixed it, but we'll find out in a minute when we try to use this. Okay, so I need to get this information out, which I've done right here. But I do want this in a different spot. So what I want to do with the game is, this is just getting static information right here. That doesn't change, so it doesn't matter. I'm checking the game, the events. Now I want to actually update the game right here. So this here, where I'm grabbing the new updated rectangle, I want this to be after I've updated the rectangle. So, and before I'm drawing it. So I want to, this is just data, static data. This is checking whatever key presses or whatever close events, any events that happened. This is updating game state. This is drawing the game. So right here, I can go text update. No, let's go. Is it text update? Update text. Wait, what did I call it originally? It is text update. So I think I'm just going to switch this name so that it matches. Just so it matches along with my other code. Not really important. Whatever you want yours to say is fine. Okay, so we have some error somewhere. Right here. Oh, sorry, this is spelled wrong. I had an A there. Okay, so no errors. So if I've done this right, and if I know I updated my logic here I've updated my logic here, so it's not the same as my original reference code. So I may have made some errors. Well, let's find out. It should be moving around the screen now. Okay, hopefully it's going to bounce. That looks nice. Okay, so it is bouncing around the screen. And it's using the rectangle to do this, and the width and the height, so imagine the X and the Y is in the top left hand corner of the H, and then the width will give you the X plus the width will give you the right side, and the Y plus the height will give you the bottom part. Now I just want to show you a simplification real quick. So right now we are doing this text update, and then after the text update we need to get with gets the game text.rect field out. Okay, but can't we just return? I do want it updated in the game state, but can we also just return it? And it's just yes, we can return it. So right here in the state t game state IO, right in here, we could just return an SDL.Rect, right? Rectangle, and it's a cint. Okay, so if we return this rectangle here, down here, after the put, we can just return text.rect. That should work just fine. Okay, so now in, I'm not sure why it's complaining there. I'm going to ignore that for a minute. So now instead of using gets to get this text.rect, we can just instead update the text and also get the new text.rect out of it. Okay, I'm just going to get rid of this. Again, I do not see why it's complaining there. I don't know what that's about. Oh, what happened? Look at this. The language server is playing with me again. Okay, it's adding in unnecessary stuff and then qualifying it under a different name and confusing the whole program. So now I'm doing the text update, and it is still putting it back into the state T, but I'm also at the same time returning it, so I can just now have access to the new updated text.rect without having to get it separately, so I can use it here. Okay, so this should still work the exact same. And it looks like it's working. Try the space bar, that worked. We have our 06 moving text up at top. Okay, let's just cover. So what we've done here is we've created defined a couple new names. We got 60 as the font size that was already there. We have this new text velocity, which is a cint. Okay, and then we've removed it from game data. We've removed the rectangle from game data, and we added it to game state. And we've also added this tuple of x and y velocity, and that we're setting initially in our initial state. We're just putting a 0 rectangle in here, but we are putting in the text velocity for both the x and the y that we have defined above. So that is now part of game state, not being returned from game data. So in our update, our load media, it's no longer, the text.rect is no longer being returned here. Instead, we are modifying game state to put the text.rect in the game state. That's going to have the proper rectangle instead of the 0 one that was initially there. And we have a new function that is text update. That is the state transformer monad applied to game state in IO. And we're getting the game state from that. And what we're doing here is we are getting the X and the Y and the width height out of the rectangle. Or we're calling it old X, old Y. And we're also getting that tuple. We're getting the old X velocity, the old Y velocity. Or I'm just calling them old because they may or may not be changed, or for the new version. So the way I'm doing this X is the let new X and new Y. I'm just using guards here to find out if it is off the screen, to tell it to change directions, and also make sure it's drawn at the edge of the screen, not off the screen. So this is allowing the update. This is saying with the update, the X coordinate with the X velocity, if that has gone off the left side of the screen, make sure it's being drawn at the left side of the screen, and make sure we change the new X velocity to the defined above text velocity. And we're doing the same thing for the right side. We're updating the X with the X velocity, but we're also adding the width to get the right side of it and making sure that it hasn't gone past the screen width. If it has, we're doing the same thing. We're backing it up so it's not off the screen width. And we are changing the velocity direction here to a negative, would be a -3. And we're doing the exact same thing for the Y. We're repackaging it up back into the text rectangle. And we're using the record update syntax to use put to put that back into the game state with the game text rect. And here is the text rect from right here. And these are just the new velocity and the new Y velocity from here and here. And we're also returning the rect. Even though we've placed it back in the game state, we're returning it too because we want to get it right here. So when we call this text update function, it's actually binding the output to text rect, so we can use it in this just text rect down here when we draw that. So that allows us to bounce it around the screen, and it's even got a little collision going on with the edges. That is going to be everything about moving text around the screen, updating. We're using the state transformer monad a little bit more now. So yeah, I hope you enjoyed that, or it was educational. Thanks for watching and have a nice day. Bye.